This is the supplemental video for properties of hydrates experiment. It is important to read the experiment prior to watching this video. And if available, watch the corresponding PowerPoint presentation to better understand the experiment. In this experiment, you'll be using a Bunsen burner. To better understand how a Bunsen burner works, one has to know the parts of the Bunsen burner. The barrel is the main upright part of the Bunsen burner, and the top part is where the flames come out. Remember not to touch the barrel as it can get very hot while in use and can stay hot long after it has stopped being used. The base of the Bunsen burner provides the support for it to stand up. It is also the safest part of the Bunsen burner to touch if you need to move or carry it, as it is designed not to get hot. The air vent or port is an opening above the gas inlet that allows air to enter the Bunsen burner, whereby it mixes with the gas. The air vent or port can be partially or completely covered by turning the collar. The collar is the adjustable metal tube that is there for covering exposing the air vent or port. This controls how much oxygen can enter the Bunsen burner and therefore how much oxygen can mix with the gas. Remember, the more oxygen that is allowed to enter the Bunsen burner, the hotter the flame will be. Always light the Bunsen burner with the air vent completely covered by the collar. Gas inlet below the air vent or port is where the gas enters the Bunsen burner and mixes with the oxygen. However, the gas flow control controls how much gas enters the Bunsen burner that mixes with the oxygen in the air. There are two main types of flames produced by a Bunsen burner. These are the yellow flame and the blue flame. The yellow flame is also known as the safety flame as it is bright yellow and highly visible. A Bunsen burner flame will burn yellow when the air vent or port is completely covered by the collar. The yellow flame is the coolest Bunsen flame because less oxygen can burn with the gas, which means the flame will not burn as efficiently. However, never use the yellow flame to heat something. Heating with the yellow flame will cause glassware and other equipment to get covered in black soot, which is difficult to remove and might affect your results. Also, since the flame is not as hot, it will take much longer to heat something. The second type of flame produced by a Bunsen burner is the blue flame, also known as the heating flame. This flame is light blue and not easy to see, especially in a brightly lit laboratory. A Bunsen burner flame will burn blue when the air vent or port is completely uncovered by the collar. The blue flame is the hottest Bunsen flame. Because the air vent or port is uncovered, more oxygen can burn with the gas, meaning the flame will burn more efficiently. There are two parts to a blue flame, the smaller, brighter section at the bottom and the larger, less bright section above. The hottest part of the blue flame is the tip of the smaller, brighter section. Only use the blue flame when you're heating something like your crucible. Since the blue flame is more difficult to see and much hotter than the yellow flame, you need to be very safety conscious when using this. Before starting your experiment, make sure to put on your lab gown and safety goggles. If you have long hair, make sure it is tied back. Also, check the glassware that you'll be using for cracks and chips. If it does, let your lab instructor know so it can be replaced. Your glassware should be clean, dry, and free of dirt, as this might affect your results. Now set up your experiment. The instructor's bench top has the model for the experiment setup as your guide. Now connect the rubber tubing from the Bunsen burner into the gas line found on your bench top. If you're planning to use a match to light your Bunsen burner, it is important that you have a small beaker, like a 50 ml beaker with a small amount of water to extinguish the lighted match. Light the match first before turning on the gas line. When your match is lighted, the safest way to light your Bunsen burner is to go below the top of the barrel and slide up. Remember, light the match first before opening the gas line, not the other way around. This will refrain from saturating your work area with gas if there is a delay in lighting your match, which may cause a mild fire explosion. However, if you intend to use the safety spark striker, you may turn on the gas line simultaneously as you start to use the striker. To do this, hold the striker up and above the Bunsen burner as you see a spark. The Bunsen burner will light up. Never leave your Bunsen burner unattended. If you must leave your work area, ask a partner or lab mate to watch over it. Another equipment you'll be using in this experiment is the crucible tongs, which are scissor-like tools. But instead of having two blades, these tools are replaced with two pincers or pieces of metals that concave together that allow you to grasp your hot crucible or avoid touching it directly with your hands if necessary. It is important to practice first holding the crucible and its cover with a pair of tongs before starting part B of this experiment, which is the percent water in a hydrate. Practice will minimize breakage of the crucible and its cover. To start with the percent water in a hydrate, put the crucible and its cover on the clay triangle. Adjust the height of the iron ring from the burner flame. The blue flame should be at least 1 centimeter from the bottom of the crucible. Heat the crucible with the burner flame for 5 minutes to remove any moisture or impurities in the crucible. You must let the crucible cool before weighing it in an analytical balance because the heat from the crucible warms the surrounding air, which rises, then that air cools down and falls. This rise and fall of surrounding air is called a convection current and will give you an unsteady reading that is rising and falling. Weigh the cooled crucible and make sure to use the same analytical balance throughout the entire experiment, as different balances could be off and calibrated differently. Not using the same balance could give you inconsistent masses throughout the experiment that may give you incorrect results in the end. You should have 4 decimal places for your masses. As the procedure indicated, you must get the mass of the crucible separately without a cover in case you accidentally break the cover. Then take the mass of the crucible and cover and record in your data sheet. Now obtain a sample of the unknown solid hydrate and record the unknown number in your data sheet. Using a scopula, weigh about 1 gram of this unknown hydrate. The weight of the sample need not be exactly 1 gram, but could be plus or minus 0.01 gram. Heat the crucible with the unknown hydrate slightly ajar so that any water can evaporate from the solid hydrate. It is a good practice to start heating using a small flame, as the hydrate might splutter on a high flame, resulting to a loss of sample. Heat for 10 minutes. Turn off the burner, cover the crucible completely, and let it cool on the clay triangle first for around 5 to 7 minutes before placing it on a mat to cool to room temperature. Never leave hot crucible on the lab bench directly. Now take the mass of your cooled crucible and cover that contained the residue. Record the mass in your data sheet. Dispose the residue into the waste container found in the fume hood. Then wash the crucible and cover with soap and water. Use a sponge or scrub to remove any loose material stuck to the crucible. Show clean, dry crucible and cover to your lab instructor prior to returning this inside your drawer. Thank you for watching.